Hello, I am Sunita. Welcome to my class. Here I am going to discuss Karnataka DET Science topics according to this syllabus. Here I am going to discuss in detail the topic motion. Next one, motion. We can define motion as the change of position of an object with respect to time. Consider this example. Assume when the person started walking, this is the first initial position of the person. This is the final position of the person. Assume to cover this much distance, if he take 1 second, then this type of motion we will call, this type of process we will call it as a motion, because here you can observe change in position of an object with respect to time. Then here the motion of a bicycle, this is also an example of a motion. A car motion and train motion, these are all example of a motion. In our daily activities like walking, running, closing the door, etc., everything it will indicate motion, involve motion. There is a change of position of the object involved in these cases. Even walking, you will walk, assume you will walk within 5 minutes 1 kilometer, running within 5 minutes if you cover 2 kilometer. In both the cases also, your body it will be change its position with respect to time. Therefore, this is also best example for motion. The flow of air in and out of our lungs is also an example of motion. Breathing, this is also a best example for motion. The automobiles that carry passenger from one place of pickup to the destination possess motion. In this case, the position of passenger is changed from one place to another. Here assume you are traveling from Mysore to Bangalore. Mysore to Bangalore, you can observe so many stops they will give in the bus. Maybe first you will get Srinagarpatna, then your position of the body with respect to time it will be changes. Then you will go to next to Mandya, then your position with respect to times it will be go on changing as the bus is approaching to Bangalore. These are all the best example for motion. Next one is uniform motion and non-uniform motion. Uniform motion, when an object covers equal distance in equal intervals of time, then its motion is said to be uniform motion. Let us discuss here. Assume here the car is moving from one point to another point. It will cover a distance 16 meter, time 8 seconds. Here they are given intervals. Here every 2 seconds it is covering 4 meters. Therefore, at constant time it is covering constant distance. This type of motion we will call it as a uniform motion. Therefore, it is covering equal distance in equal interval of time. Here the distance is each and every 2 seconds it is covering 4 meter. Therefore, constant distance it is covering with a constant time. This type of motion we will call it as a uniform motion. The next one, non-uniform motion. When an object covers an equal distance in equal interval of time, then its motion is said to be non-uniform. Here also the object it is covering every 2 seconds. Assume first 2 seconds it will covers 2 meter. Then next 2 seconds if it is covers 6 meter. Maybe next 2 seconds it will covers like 8 meter. Then maybe later it will be go on slowing. Then here the time it will be same. The time you are considering each and every 2 seconds, but the distance covered by the car is not equal. This is unequal. This type of motion we will call it as a non-uniform motion. Motion is mainly described in terms of the distance and also displacement. Listen here, this is the point A, this is the point D. Assume for example this is your home. Point A represent home, point D represent your school. Then here if you follow this curved path, if you reach the school from home to school, this curved path it will indicate a distance. Therefore, distance is nothing but total length of the curved path. This is the total length of the curved path. We will call it as a distance. Then displacement is the shortest distance between your home and school. We will call it as a displacement. Here distance, maybe you will follow this path, maybe you will follow this path, maybe you are having different paths you can reach the point D. Distance may be vary, but in the case of a displacement, it will be the shortest distance between your home and school. It will not at all change. Therefore, displacement will be constant for a particular example. Then consider here distance from A. This is your home. You will follow this path A, B, C, D. Then you will reach the school. Then after completion of the school, again you will follow this path D, C, B, A. Again you will reach your home. Then this total length covered by the curved path, we will call it as a distance. Displacement again. You will leave your house, then you will reach the school. After completion of the school, again you will reach your home. Here in the case of a displacement, the initial and final position will be the same. Therefore, displacement will be 0, because displacement is nothing but the shortest distance between the initial and final position. You have to understand that one, the shortest distance between initial and final position. In this case, the initial, because first you will leave house, again you will reach school, again after the completion of the school you will reach home. Then here initial and final position is your home only. You are meeting at the same point. Therefore, in this case, displacement will be 0. Understand, remember the point. Displacement will be 0, but distance cannot be 0, because distance is total length covered by the curved path. Okay. Speed and velocity. Speed is defined as the rate of change of distance. How much distance you are covered with a particular time, we will call it as a speed. Speed is a how fast you are traveling. Then this car is traveling with a speed of 20 meter per second. This 20, it will indicate only the magnitude. Magnitude is nothing but number. It will not show any direction. Speed, it will not show any direction. Then here, therefore, speed is a scalar quantity. It will show only a magnitude. Then velocity. Velocity is defined as the rate of change of displacement. Then here, velocity, it will show the magnitude and also direction also. Therefore, it is a vector quantity. Here it will represent the velocity of the car. 20 meter per second is 20 is the magnitude of the distance. Then east, it will show the direction. But speed and velocity, they have the same SI unit. Here one thing you can observe, in speed we will consider distance. Distance is also a scalar quantity. Distance is nothing but how much distance the car it will cover. Whether it will involve a curved path, straight path, that it will not matter. But what is the total distance, how much length it will cover, that is nothing but a distance. Velocity is nothing but displacement divided by time. Displacement is nothing but shortest distance covered by the car with respect to time. It will show the direction. Therefore, this is a vector quantity. Assume you are traveling from Bangalore to Mysore. Then speed, it will indicate how much speed you are going. But velocity, it will indicate the direction also. That is the main difference between speed and velocity. Types of motion. We might have noticed that different objects move differently. Some objects moved in a curved path, some in a straight path, and few other in a different way. According to the nature of the movement, motion is classified into 3 types. According to which type of motion you will follow, the motion we can classify it as linear motion, rotatory motion, oscillatory motion. Linear motion. In linear motion, the particles move from one point to another in either a straight line or curved path. The linear motion depends upon the path of motion is further divided as follows. Linear motion, either it will follow a straight line or curved path, depends upon they are given different names. First one, rectilinear motion. the path of the motion is a straight line. Always remember, rectilinear is nothing but the motion, it should be straight, otherwise it will involve a straight motion. Here consider this example. The three cars or three vehicles, they are moving in a straight line. Therefore this is an example of a rectilinear motion. Here the soldier or police, they are doing march fast and they are following a particular line. This is also an example of a rectilinear motion. Here you can observe cycling is going on. Here he will follow a straight line. This is also an example of a rectilinear motion. Therefore rectilinear is nothing but always it will follow the path of the motion is always a straight line. Curvilinear motion. The path of the motion is curved. The path of the motion, if it is follow a curved, then it is a curvilinear motion. Motion of a roller coaster along its track. Here you can see the track. The track, it is in the form of a curved. Then the roller, it will move in this one. Then this is an example of a curvilinear motion. Then here motion of a fighter jets during national parade. This also jets, they will move in the circular path. This is also an example of a curvilinear motion. A few example of linear motion or the motion of the train, football, the motion of a car on the road, etc. Here linear motion, you are having two types. One is rectilinear, another one is curvilinear. Rectilinear, always the motion, it will follow a straight line. Curvilinear motion, it will occur, the motion, it will occur in a curved path. The 2 points you have to remember. Oscillatory motion. Oscillatory motion is the motion of a body about its mean position. This is the mean position. The motion of a body about its mean position, we will call it as a oscillatory motion. Then here you can observe two girls, they are sitting at the two ends. When she pushes down, then she will move up. Then you can observe in the opposite also. Then you can see the up and down movements in mean position. This is an example of a oscillatory motion. Then here when a child on a swing is pushed to and fro, here also when she pushed, then she will come down, then she will move back. This is also an example of an oscillatory motion. Then here the pendulum of a clock, you can observe in the pendulum of a clock. This is also example of oscillatory motion. You can observe a to and fro motion. In guitar also you can observe a to and fro motion of an object. Oscillatory motion, you have to remember the to and fro motion of an object about its mean position. Equation of motion. Equation of motion for uniform acceleration. What is meant by uniform acceleration? Uniform acceleration is nothing but rate of change of velocity with respect to time. How the velocity it will be changing with time. If the velocity is changing constantly at a particular time, that one we will call it as a uniform acceleration. In case of a uniform acceleration, there are the three equations of motion which are also known as the law of constant acceleration. This is the three equation, we will call it as a law of constant acceleration. Hence these equations are used to derive the components like this one. We will use to derive the components like displacement, it is indicated by S. Velocity, we are having two types, one is initial, another one is final. Time T and acceleration A, therefore they can only be applied when acceleration is constant and motion in a straight line. The three equations are here, they are given the condition. When acceleration is constant is nothing but when acceleration it will involve uniform acceleration. Motion along a straight line, always it will represent a motion, it should be in a straight line, it should be a linear motion. The three equations are V is equal to U plus AT, V square is equal to U square plus 2AS, S is equal to UT plus of AT square. Here this capital V is the final velocity, small u is the initial velocity, A is the acceleration, acceleration, t is the time, here s is the displacement. These things you have to remember. These equations are referred to as SUVAT equation, where SUVAT stand for displacement S, initial velocity U, final velocity V, acceleration A, and time t. These three equations are very important. This equation you have to remember. This is the equation of motion. Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. This postulate is known as the law of inertia. Consider here the football. It will be on the table. If you are not touching any football, if you are not putting any force on it, then it will be in that position only. Maybe hours stay together. This position we will call it as a law of inertia. An object is at rest, will remain at rest unless a net force act on it. If you are not applied any force, then there is no change in the position of the football. It will be remain at the rest position only. Then assume next case, if you apply a little force, then that football it started moving, then leave that one, it will be go on moving up to a certain. That is also a example of Newton law of motion. It will be at rest or keep moving in a straight line. It will be moving in a straight line at constant speed unless it is acted upon by a force, unless if you applied any opposing force. Otherwise, if you applied more force, then it will move fastly. If you not applied any force, simply touched and leave, then it will be moving in a straight line without disturbing it. This is also an example of a Newton first law of motion. Remember always Newton first law, it will follow the object, it will move in a straight line. If the object is at rest, if you not applied any force, then that object it will not change its position. That one we will call it as a law of inertia. The next one, if you apply less force, then the football it will started moving. Then if you not applied any extra force, it will be continuously with constant velocity, it will be moving. This is also a law of inertia. Then Newton first law, we will call it as a law of inertia. Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. The rate of change of momentum means how much momentum if you apply to a particular body is directly proportional to the applied unbalanced force. Here F is the force applied, M is the mass of the body, A is the acceleration of the body. Let us see first what is meant by momentum. Momentum is a physical term. It refers to the quantity of motion that an object has. When the object is moving, then how much quantity or what is the value of motion that an object possesses, that is nothing but a momentum. Here consider this example. This is a trolley. Then here we kept one wooden box. Then if you apply a particular force, then this trolley it will started moving. Then acceleration also increases and also speed also automatically it will be increases. Acceleration is nothing but change in velocity with respect to change, how the velocity it will be changing with respect to time, we can call it as a acceleration. Here consider these two cases here. Second case, I am applying more force. Then here the mass of the body it will be same in both the cases, and weight of the trolley also it will be same. Then here when you apply more force, then acceleration of the body it will be increases and speed also automatically it will be increases. Newton's second law, what it will state that the momentum of a body it will be changes or it will be directly depends upon the unbalanced force in the direction of the force. Here they are indicated properly. It will be the unbalanced force it will be in the direction of the motion, means you have to apply a force from this direction only, not from in the opposite direction. Here in both the case also mass of the body is constant, but here you are applying force, it will be more. First case you are applying less force, second case you are applying more force. When you apply less force, momentum will be less, acceleration will be less, then speed of the body also it will be less. When you apply more force, more acceleration, more momentum, and speed of the body also it will be more. Therefore, according to Newton's second law of motion, the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. Let us mathematically derive Newton's second law of motion. From Newton's second law of motion, rate of change of momentum is directly proportional to applied force. What is meant by directly proportional? Listen here. Directly proportional means when one thing increases, other also increases. Speed is directly proportional to distance, means if speed increases, distance also increases. If speed decreases, distance also decreases. Directly proportional means they will be directly depends upon each other. Therefore, force is directly proportional to rate of change of momentum. Then force is directly proportional to change in momentum divided by time. Rate is nothing but rate, it will represent a time. Change in momentum divided by time, it is nothing but rate of change of momentum. Then what is mean by change in momentum? Change in momentum is nothing but final momentum minus initial momentum divided by time. You know final momentum is m into v minus m into u is the initial momentum. M is indicated mass of the body. V it will indicate final velocity of the body. Then here again M is mass of the body. U is initial velocity of the body. You know momentum P it will be equal to M into V. Momentum is the product of mass into velocity, that already you know. Here they are asking final momentum minus initial momentum. Therefore we have to consider this one. Then force is directly proportional to m into, take m as a common, then you will get v minus u divided by t. V minus u, you can, this it will represent a change in velocity divided by time. Change in velocity divided by time is nothing but acceleration. Therefore f is directly proportional to m into a, otherwise f is equal to ma. That is the mathematical equation for Newton's second law of motion. Newton's third law of motion. Newton's third law of motion states that to every action there is an equal and opposite reaction. The action and reactions are equal and opposite. For example, consider this is the rocket. The tip of the rocket is narrow. The bottom of the rocket is filled with fuel. If you put a fire on fuel, then hot gas comes out of the nozzle, then the rocket it will move up. How much calorie of if the fuel is having more calories, then if it is burns it will gives more energy, then the rocket that much heat it will supply to the rocket, that much energy is supplied to the rocket, then rocket it will move with a high speed. Therefore here the calorific value of a fuel it will depends upon the speed of the rocket. Therefore this fuel, the force on the gases, this it will be the action, force on the rocket, this will be the reaction. Action and reactions they will be in opposite direction, and the action and reaction force it will be equal, or energy it will be equal. Consider another example here. Take a balloon, blow the balloon with air, leave the balloon, then here the air it will comes down, then the balloon it will moves up. Then how much fastly the air it will comes down, that much fast the balloon it will moves up. Therefore this is an action, this is an reaction. Action and reactions they are opposite but equal in magnitude. Here also, if this boy want to jump, otherwise want to reach the land, he has to put force on this boat. If he put more force, then more easily he can jump, otherwise more distance he can jump easily. Then putting a force on the boat it is an action, jumping on the land it is a reaction, both also in opposite direction. Therefore Newton's third law of motion, to every action there is an equal and opposite reaction. The action and reactions are equal but they are in opposite direction. Let us solve some of the few multiple choice questions based on the topic motion. A particle is moving in a circular path of radius r. The displacement after of a circle would be option A 0, option B pi r, option C 2r, option D 2 pi r. The correct answer is 2r. If a particle is moving in a circular motion, then from here to here we will call it as a radius. Then if this particle, if it is cover of a circle, means from here to here, this straight line, it will represent of a circle. From here to here we will call it as a radius. Again from here to here radius. Then here 2 times of the radius, the particle, it will cover the distance or displacement. Therefore the correct answer is 2r. 2r is the correct answer. Next one, the numerical ratio of displacement to distance for a moving object is option A always less than 1, option B always equal to 1, option C always more than 1, option D equal or less than 1. The correct answer is equal or less than 1. Here they are asking the numerical ratio of displacement to the distance. The correct distance for a given moving object is always equal or less than 1. If the displacement of an object is proportional to the square of time, then the object moves with A. Uniform velocity, B. Uniform acceleration, C. Increasing acceleration, D. Decreasing acceleration. The correct answer is uniform acceleration. In the case of uniform acceleration, an object covers a distance with constant velocity at a regular interval of time. It will follow a constant velocity at each and every point of a time. Here, therefore, here the displacement of an object is directly proportional to the square of the time in the case of a uniform acceleration. From the given velocity versus time graph, it can be inferred that the object is velocity time graph. This graph, it will indicate option A uniform motion, option B at rest, option C in non-uniform motion, option D moving with uniform acceleration. You know, uniform motion means an object covers equal distance in equal interval of time. Therefore, consider every 2 seconds the object is covering 4 meter. Then after 2 seconds again 4 meter. Therefore, when you plot a graph between velocity time, then you will get a straight line. This straight line, it will indicate the object is in moving uniform motion. Suppose a boy is enjoying a ride on a merry-go-round which is moving with a constant speed of 10 meters per second. It implies that the boy is dash at rest, B moving with no acceleration, C in accelerated motion, D moving with uniform velocity. The correct answer is in accelerated motion, because the boy is enjoying a ride. He is moving in a ground. He is riding in a ground with a constant velocity 10 meter per second. Therefore, the velocity changes, it will be a constant. That type of motion we will call it as a accelerated motion. In which of the following cases of motion the distance moved and the magnitude of displacement are equal? In which case the distance of an object, it will be equal to displacement? They are asking the question. First option, if the car is moving on a straight road. Second option, if the car is moving in a circular path. Option C, the pendulum is moving to and fro. Option 4, the earth is revolving around the sun. The correct answer for this question is if the car is moving on a straight road. You know at which condition the displacement of an object is equal to displacement. Only one case is possible. If the object is moving in a straight line, then displacement, it will be equal to distance. When a body performs a uniform circular motion, it has dash a constant velocity, Option B, a constant acceleration. Option C, an acceleration of constant magnitude but variable direction. Option D, an acceleration which changes with time. Option C, assume here if an object is moving in a circular path, the acceleration it will be constant in magnitude in all the cases, but when it is changing the direction, see from here to here, again it will do, you can see observe the direction of the movement of the object, it will be go on changes. The rate of change of displacement is called option A, velocity. Option B, deceleration. Option C, acceleration. Option D, speed. The correct answer is velocity. The rate of change of displacement, we will call it as a velocity. Acceleration is a vector quantity which indicates that its value is option A is always negative, option B is always positive, option C is 0, option D can be positive, negative or 0. Acceleration is a vector quantity. It has both magnitude and direction. Therefore, acceleration can be positive, negative or 0 also. That is the correct answer. For a particle moving along a circular path, the angular velocity vector is directed. Option A, along the radius towards the center. B, along the radius but away from the center. C, along the tangent to the circular path. D, along the axis of rotation. The correct answer is D, along the axis of rotation. In the case of circular motion, the center of the circle or the center of the motion, it will be important. The center we will call it as a axis of rotation. Therefore, for this one, the correct answer is along the axis of rotation. In this uniform circular motion, the angular velocity vector is directed towards along the axis of rotation. A particle performing a uniform circular motion, A has a radial velocity, B has a radial acceleration directed towards the center, C has a tangential acceleration, D has a radial acceleration directed away from the center. Option B is the correct answer. A particle performing uniform circular motion has a radial acceleration. Acceleration will be there directed towards the center. Radial acceleration always it will point towards the center. Therefore, that is the correct answer. An object moves along a circular path. When the object is moving in a circular path, the following quantities may remain constant during its motion. Option A, speed. Option B, velocity. Option C, magnitude of acceleration. Option D, both A and C. The correct answer is option D. Both A and C means speed and magnitude of acceleration, it will be constant when the object is moving along a curved path. Always remember, when the object is moving in a curved path, then speed, magnitude of acceleration will be constant. In circular motion, the radius vector, option A, has a constant magnitude and direction. Option B, changes in magnitude and direction. Option C, changes in magnitude but has a fixed direction. Option D, changes in direction but has a fixed magnitude. Option D is the correct answer. In the case of a circular motion, the radius vector changes in direction but has a fixed magnitude. The direction of the radius vector, it will be changes, but radius of the circle, it will be constant. For a particular center, for a particular circle, the radius, it will be constant, but only the direction, it will be changes. An object may have option A, varying speed without having varying velocity. Option B, varying velocity without having varying speed. Option C, non-zero acceleration without having varying velocity. D, non-zero acceleration without having varying speed. Correct options are B and D. An object may have varying velocity. Velocity may be varying without having varying speed. Maybe sometimes speed may be constant, but the velocity may be differ or change. Then D, non-zero acceleration. Acceleration may be zero without having varying speed. Maybe in sometime acceleration may be zero. Sometimes speed may be constant. Mark the 3 correct statement for a particle going on a straight line. When a particle is moving in a straight line, which are the 3 statements correct? They are asking the question. First one, if the velocity and acceleration have opposite sign, the object is slowing down. The velocity and acceleration, if they have the opposite sign, or if one is plus another one is minus, then normally the object it will slow down. That is correct. If the position and velocity have opposite sign, the particle is moving towards the origin. Yes, this is also correct. The position and velocity, if they have opposite direction, the particle is moving towards the origin. Then D, if the velocity is 0 for a time interval, the acceleration is 0 at any instant within the time interval. This is also correct. Only C1, if the velocity is 0 at any instant, the acceleration should also be 0 at that time. This one is wrong. What does the slope of distance time graph give? First one, acceleration. B, uniform speed. C, speed. D, both B and C. In the slope of distance time graph, it will indicate the speed. That is the correct answer. It will indicate the speed of the object. An example of a body moving with constant speed but still accelerating is option A, a body moving with constant speed on a straight road. Option B, a body moving in a helical path with constant speed. Option C, a body moving with constant speed in a circular path. Option D, a body moving with constant speed on a straight railway track. The correct option is a body moving with constant speed in a circular path. When a body is moving in a circular path, moving with a circular path with a constant speed, but still it will show an acceleration, because when it is moving in a circular path, speed it will be constant. Then each and every time it will change the direction. Because of the change in direction, the acceleration also it will be go on changing. Therefore the option C is the correct answer for this question. Next one, velocity time graph of an object is given below. The object has uniform velocity, B, uniform speed, C, uniform retardation, D, variable acceleration. In velocity time graph of an object, it will follow a uniform retardation. Therefore C is the correct answer. The ratio of speed to the magnitude of the velocity when the body is moving in one direction is option A, less than 1, option B, greater than 1, option C, equal to 1, option D, greater than or equal to 1. The correct answer is option C, equal to 1. The ratio of speed to the magnitude of velocity. When a body is moving in one direction, speed divided by velocity, the magnitude, the ratio of speed divided by velocity, it will be always it will be equal to 1. But condition is the body is moving in only one direction, single direction. Area under a velocity time graph represent a physical quantity which has the unit. First option meter square, second option meter, third option meter cube, fourth option meter per second. In velocity time graph, everything we will measure in terms of a physical quantity, that quantity which has a unit. Option B, meter. Which of the following figure represent uniform motion of a moving object correctly? What is mean by uniform motion? If an object covers equal distance in equal interval of time, then that object it will possess a uniform motion. When you are considering uniform motion, time is also constant, distance also constant. When these two quantities are constant, then you will get a line passing through the origin. Therefore, this is the correct answer for this question. It will represent the body, it will possess uniform motion. Thanks for listening my class. Send me your valuable feedback. Here I discussed the topic motion. Then I solved some of the MCQ questions based on the topic motion. Then now onwards I will take each and every class I will pick up one important topic. Then I will discuss in later. Then I will solve some of the important MCQ questions. All my classes are very important. This it will helpful to clear your TET exam. Follow all my classes regularly. Thank you.